Hi everyone, welcome back to Code with me Manasa. This is the part 6 of our data science series. In the last video we talked about very introduction to the beginners of machine learning. So in this part we talk about data cleaning and pre-processing. So we are covering the most important topics here in the entire field of data science. So many beginners think data science is all about machine learning models, but truth is nearly 80% of data scientists time is spent on cleaning and preparing the data, because data is the most powerful weapon in data science, because every model, every algorithm and every process is based on the data only. So cleaning and preparing the data as we needed is very most important in data science. So clean data means better insights, better accuracy and better models. So let's get started. So why to clean data? So why data cleaning is matters in data science? Here data cleaning is extremely important because 80% of time goes into cleaning. So before building any model, the majority of the work involves removing errors, removing outliers, next correcting formats and making the data consistent to like which model we have selected. We have to train this data to that model, so that model should be successful at last in the deployment stage. So that's why every data scientist first point of taking data science is data cleaning only. So clean data is equals to high model performance. So even the best algorithms will fail if the data is messy. So clean versus messy. So let's see uh, like how clean and messy data are differ. So clean data looks structured, organized and consistent. So messy data is full of missing values, duplicates and errors. So data cleaning is the foundation of every successful data science project. So next, see what is raw data. So raw data is the very first version of data you get from from many platforms. You'll get the data. So for example, websites, sensors, surveys or any other logs or from databases also. So raw data is usually messy and unstructured. So it contains missing values, errors, duplicate records, invalid formats and outliers also. So this raw form cannot be used directly. So if we use this raw form, will not get the data science model ready, and we need to clean and pre-process it to make it machine learning ready. So how much the data is clean and clear and consistent, the machine will learn that much. So let's see. Let's see what are the common data issues in machine learning and data science. So when dealing with real world data sets, we commonly see these issues like missing values, outliers, duplicate records, inconsistent formats, incorrect data types. So each of these issues affects the quality of the analysis. Let's understand them one by one. Let's see what are missing values. So missing values are nothing but they'll appear in the form of null empty cells. So they are so why, and they also have blank cells, or they also have some special characters like question mark or hyphen or underscore like that. So why do missing values happen? So users skip fields, sensor fail or data entry errors because it is a human error. So data entry is done by a human, so it may be a human error or it may be a system error. So missing values must be handled carefully because they can break ML models or bias the entire analysis. So how to handle the missing data or missing values? So there are multiple strategies to fix missing values. So there are delete rows. So if the data set is large and only a few values are missing, you can remove them. And next, replace the mean or median or mode in the place of missing values. So mean is for numerical data, median is for skewed data, mode is for categorical data. So next we'll use forward or backward fill. So use these fill is used in time series data. Next is predict missing values. So use machine learning. Here also we can use machine learning to estimate or predict the missing values. For example, let us see an example. Df of age, fill NA, df age, median. So in place 2, here in the place of missing values, median is filled. So this replaces missing ages with the median age. So it helps a lot. Other than having a missing value, median, mean or mode is very helpful. So next, this is an example you can run in Jupyter Notebook. I'll also explain how to run programs in Jupyter Notebook or VS Code or PyCharm in the coming videos. But you can run this example in your Jupyter Notebook now. Next, what are outliers? Outliers are extreme values that don't fit the normal pattern of the data. For example, if 90% of customer ages are between 20 and 50 and one age is 140, that's an outlier. So outlier can distort averages, affect model accuracy and create wrong interpretations. So how to detect outlier? So we don't know what are the outliers, or as we see the data we can understand now what are the outliers, but how to remove that outliers is a big challenge. So we can detect outliers using IQR, interquartile range. So points outside quartile 1 to 1.5 and quarter 3 to plus 1.5 quartile. And next, z score, values above +3 or below -3. Using z score also we can remove outliers, and using scatter plots shows visually how far a point is from the cluster. So cluster in the sense, I have said an example that all the ages, customer ages are between 20 to 50, means 20 to 50, the difference between 20 and 50 is small, and the difference between 50 to 140 is large. So the point of 140 will be away from the 50. So that is the scatter plot, and it shows that is the outlier, and we can remove that. So outlier detection is critical skill for every data scientist. Next, how to handle outliers? To handle outliers, uh, we remove outliers. If you want, you can remove outliers, delete extreme points if they are errors. Next, cap values, like replace extreme values with boundaries. So we have, like, we take 140 age, so we can replace, if you want to replace it with 50, or other than 50 you can use 55. So next, using log or square root transform, so reduce the effect of extreme values. Each method depends on the problem and dataset. So next, see categorical coding. So machine learning models cannot understand text, so they use only understand numbers. So we convert categorical values into numeric values using label encoding and one hot encoding. There are two types of encoding, label and one hot encoding. So there are two types of categorical data also, nominal and ordinal data. So nominal is nothing but city, color. Ordinal is nothing but it has an order. Like, let us take an dress example. It has sizes, like from XS to XL or double XL, like that. So S, M, L, like that we will have a as an order. But in nominal data there is no order, like city, color, age, name, it has no order. So like this, data is categorized. And what is, let's see, one hot encoding. So if you have a column like city, like Delhi, Mumbai, and Chennai, so one hot encoding converts it into Delhi. What is Delhi? It is a city. And what is a Mumbai? It is a city. And Chennai, it is a city. So let us take here PD dot get underscore dummies of df of city. So here this code is used for get dummies from city. So we have city Delhi, city Mumbai and city Chennai. It will get the dummies from the dataset. So in Python, this code is used in Python. And next, what is label encoding? So label encoding assigns number to categories. Like we'll take an example of gender. So for male it will give 1 and female it will give 0. So in Python code we use this code. You can run this in Jupyter and you can see the output. In coming videos I'll also explain about how to run the code and how to solve the errors, solve the outliers, and how to use label encoding and one hot encoding like this. So this is the common use for ordinal data or when converting categories to numeric. So let's see why scaling matters. So scaling is essential because different features have different scales. Example, age ranges from 0 to 100, salary ranges from 0 to, let's say, 10 lakhs. So models like KNN, SVM and neural networks get biased by large values. So scaling ensures all features contribute equally. So next, let us see standardization. Standardization transformed data so that mean is equals to 0, standard deviation will be 1. So this is the code for uh, getting the standardization value. So this is the most commonly used in scaling method. So next, normalization. So normalization scales values between 0 and 1. So in Python this is the code from scikit-learn preprocessing, importing min max scalar. So min max is nothing but minimum and maximum scalar. We are using that. And here scale is equals to min max scalar dot fit underscore transform of df. So what it does, it normalizes the values between 0 and 1. So it helps the data should which do not contain missing values and which do not contain outliers, and it helps in efficient modeling. So next, let's see feature engineering. So in feature engineering is the process of creating better features from raw data. For example, binning ages into categories. So extracting year, month, day from date. So text processing, removing stop words, stemming. Next, creating new columns like profit is equals to revenue minus cost. So this step boosts model performance significantly. So let's see the pre-processing pipeline. So every data science project follows the pipeline. Collect data, clean data, handle missing values, that is before encoding, and encode categorical data. Next, scaling is very important. It scales the numerical data. And next, feature engineering and train the model. So this pipeline ensures the data is ready for machine learning. So let's quick summarize the key topics. Missing values, outliers, categorical encoding, scaling, feature engineering. These steps are essential to build reliable and accurate machine learning models. So thank you for watching part 6 of the data science series. If you found this video helpful, please like, subscribe, comment and share. Your support motivates me to create more high quality content. This is Code with me, Manasa, and I will see you in part 7 with new interesting topic. Thank you so much.